All right, question number 12. It's asking you which one has non-zero dipole moment. So it's asking you which one is polar. So what you're going to do, you're going to do loose structures and then find out which one is non-polar, which one is polar. So let's work on that one. Beryllium, what? 2 chlorine. So beryllium has 2 valence, and then chlorine has 7 valence. So we have 7 times 2. So a total of 16 electrons. For boron, we have 14 electrons in total. And for boron 3 fluoride, boron has 3, fluorine has 3 times 7 is going to be 24. And then iodine has 7, and bromine is 7, that's 14. And then for carbon is 4, oxygen is 6 in each. So 6 times 2 is going to be 12 and 16 electrons. Okay, so we get all the electrons. So let's work on the beryllium dichloride. Beryllium, chlorine, chlorine. So 2, 4 used up already. We have 12 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So here, beryllium, boron, lithium, these are exceptions. All right. So these are going to form only 2 bonds. They're not going to make octet. Okay, so here this is going to be a linear structure. If it's a linear structure, so it's going to be a symmetric molecule, so it's going to be a nonpolar, right? So as we see here, there's no polarization. The cloud will be just a linear, and the one side of the chlorine, and one side of the chlorine, and another side of the chlorine. Another side is also chlorine, so it's going to be a nonpolar molecule. The same thing here, bromine. Bromine, we have 14 electrons, make a single bond, so we have 12 left, and I use 6 in here, 6 in here, 6 in here. So they're all octet. This is going to be a symmetric cloud. This is going to be a nonpolar as well. So boron 3 fluoride, boron, fluorine, fluorine, and fluorine. So we have 3 for boron, so we got count 24. 1, 2, 3, 18 left. 6 in here, 6 in here, 6 in here, makes 18, 16. I'm sorry, 18, and then we run out all electrons, so it's going to be boron with 3 electrons around it. So this is going to be a trigonal planar. Again, this is another exception, as I stated here on the left. This is trigonal planar, so this is going to be a trigonal planar geometry while you have a very symmetric cloud. Okay. So iodine and bromine, let's make a single bond. We have 12 left, and then here we used up all electrons. They are all octet now, but the problem here is that bromine is more electronegative than iodine. When you look at the table of electronegativity values, electrons will be towards to the bromine, right? So you'll have the negative side of the molecule and positive side of the molecule, so you'll have a non-zero dipole moment. So answer will be D. Why not E? Carbon, you're going to have this loose structure. It's going to be one side on the carbon, another side of the carbon, we have both oxygens. So it's going to be a symmetric cloud like this, right? So there will be no negative side and positive side of the molecule. So this is question number 13. 14 is asking you what is the hybridization state of the carbon indicated by the arrow. So what is the hybridization state? You're going to count the number of electrons around this atom. So we have one cloud, another cloud, and another cloud. So we have only 3 clouds. If you have 3 clouds, it's going to be sp2. If you have 4, sp3. If you have 2, sp. If you have 5, it's going to be sp3d. All right. So you just count the number of clouds. For example, here 1, 2, 3, sp2. 1, 2. Now for one hydrogen, another for another hydrogens because you have 2 hydrogens in here. So 4 is going to be sp3, right? Okay, so let's do 15. Indicate the type of hybrid orbitals used by the essential atom of carbon tetrachloride. We have done this molecule already. I'm just going to draw it the way it is. Chlorine here. That's going to be the structure. All right, so here we have 1, 2, 3 pairs of electrons around the central atom. If you have 4, it's going to be sp3, right? What would it be hybridization for iodine with 5-fluoride? Exactly the same thing. You're going to find out how many electron pairs or clouds around the central atom, so you can find out the hybridization state. All right. So here, iodine in the central atom, fluorine, and then we got 5 fluorines. I'm going to do 1, 2, 3, 4, 5 pairs of electrons. So I use up 10. So we got 7 times plus 5 times 7. So 35 right there, and 42 electrons in total. Alright, we get 42 electrons. So I use up 10 already. We have 32 left. 1, 2, 3, 4, 5, 6. 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. We used up 30 of them, and then we have 2 left. It's going to be on the iodine. So how many pairs of electrons we have on the central atom? 1, 2, 3, 4, 5, 6. That's going to be sp3, d2. All right, if it's 6, it's going to be sp3, d2. So basically, you just count the number of clouds around the central atom. If you have double bond, you'll count 1. If you have triple bond, you'll count 1. But if you have a lone pair, you'll count 1 as well. All right, so all the bonds will count 1, and the lone pairs will count 1 too. So hybridization, question number 17, hybridization of central nitrogen atom on NO2. So nitrogen here, oxygen, oxygen, and then we have 5 valence for each nitrogen and plus 6 for oxygen, and we have 16 total of electrons. I'm going to make a single bond in between these two atoms, and then we have 4 U's already, so we have 12 left. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and then we run out of electrons. Now what? No one. We want to make the central atom as octet as well, so I'm going to move this 2 electrons right down there. So now this is not going to be enough. I'm going to move another one. So now it's good, right? This is oxygen. So what is a hybridization here? Well, that's going to be 2, right? We have 1 cloud, another cloud, so it's going to be 2, so sp. That's very easy, right? So on question number 18, it's going to ask you what is how many pi bonds we have on this molecule. The first bond is called sigma. The second ones are called pi, and the third one as well pi. All right. So this is pi. All right. So this is pi here. So here we got 2 pi's. So 2 pi's in here, 1 over here is going to be 3 pi bonds. 3 pi bonds. All right, that's all what I have for chapter 8. Please watch the videos on the content. So if you have any questions, please email me. All right. Have a wonderful day.